Hello friends, in my previous video I have explained about two electronic components, diac and triac. I have explained how and when they are activated. The key points about these two components are about diac. It will be activated after passing some specified breakdown voltage, and it will be activated after passing some specified current through gate terminal. And generally these triac and diac are used combinedly. That means diac is used along with triac. Why? To activate triac, to trigger the component triac, diac is used along this triac. But once think, what will happen after they are activated? Suppose some specified current is passed through this gate terminal, so it will be activated. Now will it offer any resistance or will it act as short circuit? So a small resistance is there, but we can ignore it. So it activates as a short. You may know about the properties of a circuit in which there is some capacitance and there is some resistance. When a capacitor is connected in AC supply, it continuously charges and discharges because AC supply is varying in voltage, so it continuously charges and discharges. But for one complete cycle, input signal waveform. So for one complete cycle, how many times a capacitor charges and discharges? So that frequency, on which parameters that frequency of charging and discharging process depend. So in a capacitive circuit, the number of charges and discharges of a capacitor depend upon two parameters. So time constant. Time constant. What is a time constant of a capacitor? How much time is required to charge a capacitor such that it gains 63.2% of our applied voltage. What is a time constant? How much time is required to charge a capacitor such that it develops 63.2% of applied voltage across a capacitor? So what we can say is, if time constant is more, the time for charging and discharging processes takes more time. If time constant is less, so the number of charges and discharges will be more. On which parameters time constant depend? Means time constant tau is equal to RC. That means R is resistance and C is capacitance. So capacitance, in modern fan regulators, capacitance is fixed capacitor we use, but what we can vary is resistance. We can vary resistance by turning a small knob. That means it's called potentiometer. If resistance increases, tau also increases, time constant also increases. If resistance decreases, time constant also decreases. So now we will see what we are doing by increasing or decreasing time constant. What is a time constant? The time required to charge a capacitor such that it develops 63.2% of applied voltage. So if time constant is more, the the number of charges and discharges will be less. If time constant is less, the number of charges and discharging process will be more. So we are varying time constant by increasing or decreasing resistance across that circuit by turning a simple knob. But what we are doing actually is, now we will see. So initially, when 220 volts is connected across this circuit, current flows in this way, and here it comes. But initially, consider this gate supply is not passed, so it will be not activated. So it will act as a open circuit. So current doesn't flow this side because infinite resistance is here. So it will choose this path only. So current flows from this side and this side, and here it comes. And initially, when AC voltage is applied, it acts as a short circuit. So current chooses this path. So current is flowing through this side, and this side. Why doesn't it go this side? Because initially this here a small resistance is offered. It acts as a short circuit. So current doesn't go this side. If it goes this side, it will be obviously activating diode component. Then it will be passing through gate terminal and it will activate triac. But initially, until the capacitor is charged, current only comes, maximum amount of current flows this side only, and its minimum ignorable current flows this side. But that cannot activate diode component. So once the capacitor is fully charged, it acts as open circuit. That means current develops through this capacitor, also flows in opposite direction to our input signal. So our input signal flows this side. So it acts as open. Zero current flows across this branch. So some voltage is developed across this capacitor, and some voltage we are providing 220 volts AC supply we are providing. So they both, this current and this current, have only one way to flow, this side only. So these two currents, I1 and current through our capacitor I2, there is only one way to flow for both these currents I1 and I2. So these two currents combinedly flow this side. So they will be able to activate our diode component, and after activating diode component, it acts as short circuit. So the current flows this side and through gate terminal and activates triac component, and it acts as short circuit. So maximum amount of, at that case, maximum amount of current flows this side. So it's, our load is directly connected to our 220 volts AC supply. Now what we have to observe is, when it is activated after it is fully charged, it discharges, and our input signal is there. These two currents I1 and I2 combinedly activate diode component, and lot of current passes through gate terminal and it will activate triac component. It will be shorted. When it will be activated, once our capacitance is fully charged, it will be activated. But how much time does it take to fully charge a capacitor? That depends on our resistance and capacitance. Actually here in regulators, capacitance is fixed, but resistance across the circuit is variable. So By varying this resistance, we can reduce or increase the time for a capacitor for charging. If it is charged in a less time, so in a less time it will be shorted. And if it takes more time to charge this capacitor, and it takes more time to short this. So if our time constant is less, more number of times triac component will be shorted. If our time constant is more, less number of time our triac component will be shorted. So if our triac component is activated more number of times, more power is passed through the load, and if it is activated less number of times, less power is passed through our load. So friends, I hope you got a clear idea about working of an electronic fan regulator. Mainly it depends, working of an electronic fan regulator depends on two main components, and a diac and a triac. These are the two main components for working of an electronic fan regulator.